right, today we're going to look at arc length and angular displacement. And so, as you can see, angular displacement is the angle theta through which a ray OA rotates, where O is on the axis of the object and A is a point on the edge. So the formula that we're going to use is always going to be number of rotations times 2 pi. That's because theta must always be in radians. If they give you theta in degrees, you'll just convert that to radians by multiplying by pi over 180 like we did in section 4.1 earlier this week. So our first example says if a Ferris wheel rotates 2.5 times, what is the angular displacement of the people in the Ferris wheel? So theta is going to equal number of rotations. Well, number of rotations is 2.5, so 2.5 times 2 pi, and that will be 5 pi. You could leave it as 5 pi radians, or you could put it in your calculator and do 5 times pi, so 15.7. Example 2. Determine the positive radian measure of the angle that a second hand of a clock travels with a given time. So 30 seconds. Your second hand starts here, and 30 seconds it ends here. They want to know what that angle theta is. One way to look at it is to say 30 seconds over 60, or that's half of a rotation, then times 2 pi. Would be pi radians, which is 3.14 radians. $55 seconds, so again we're going to do 55 over 60. If you want to reduce that, that would be 11/12. And then we'll multiply that by 2 pi. That'd be 11 pi over 6 radians, or 11 pi divided by 6, 5.76 radians. A minute 20 seconds. Well, a minute 20 seconds is a total of 80 seconds. Because we have 60 seconds in a minute plus the 20 seconds would be 80 seconds. So 80 over 60, and that reduces to 4/3. So 4/3 of a rotation times 2 pi would be 8 pi over 3 radians, and then as a decimal, 8 pi divided by 3 is 8.38 radians. And then the next thing we're going to be looking at is arc length. So just quickly show you what we mean by arc length. You have a circle, you have some length r. Whatever this unit is, say r is in inches, your arc length will be in inches. If r is in feet, arc length will be in feet. And you have the same angle theta. This same angle theta is going to be found exactly like we found the angular displacement in the examples above. So that's not going to change. So it's going to be number of rotations times 2 pi, or whatever that angle is. It must be in radians again. And then so what we mean by arc length is this part of the circle. It's part of the circumference. And so that formula is S equals r theta. So S stands for arc length, r is your radius of your circle, and theta is your angle, your angular displacement, just like we found above. So example 3, a second hand on a clock is 6 inches long. If you want to draw a picture, great. 6 inches. How far does the end of the second hand travel in 15 seconds? So 15 seconds, here's my theta. They want to know what this distance is. Well, since my radius is in inches, when I'm done, my arc length will also be in inches. So I'm going to do my formula S equals R theta. I need to find theta first. So I need number of rotations times 2 pi. Well, 15 seconds, so 15 over 60, that's a fourth of a rotation times your 2 pi would be pi over 2 radians. So then I can do my 6 inches times pi over 2 radians is 3 pi inches